Today we are going over solving and graphing radical equations. Yesterday we simplified radical expressions. Now we're looking at radical equations. So I want you guys to do the do now, which is the first one and the second equation. Make sure you solve them and also explain for both of them why you chose your first step and what it accomplishes. Pause video if you haven't. Play it once you're done. So, for the first one, algebraically solve radical x equals 3. What would I do first to solve this equation? I'm going to square both sides of the equation. What does this allow me to do? Well, it's taking a square root of x, and then once you square it, that cancels out the square root because square rooting and squaring are inverse operations. So on the left, we are left with x and only x, so it's all by itself. And then 3 squared is 9. So we get our answer. That's all we got to do. The correct answer is x equals 9. And why did I choose to do the first step that I did to solve this equation? Well, we have to get x alone, so because I have to get x alone, I have to do the inverse operation. So, and the inverse operation of square rooting, which is happening to the x, is squaring. That gets the x all by itself. So because I have to get the x alone and the inverse operation to square rooting is squaring, that's what's being done to the x, so it gets x all by itself. Let's take a look at that second equation. We have the square root of x plus 7 equals 3. Notice that entire left side is underneath the square root with the x. So we're going to want to do something similar. We're going to want to still square both sides of the equation here. That gets the square and the square root to cancel, so we're just left with x plus 7 on the left equals 3 squared, which is 9. X is not by itself just yet, so we want to subtract 7, and we would get x is equal to 2. Now, why did we choose to do the first step we did to solve this equation? Well, the first step we did was squaring both sides, and that is to get the x alone. It's the same reasoning as the one above. That's what we are going to be doing pretty much most of this class. So I'm not going to rewrite it for you guys, but it's because I have to get the x alone. The inverse operation of square rooting is squaring. That's going to get our x plus 7 alone, and then we're going to subtract 7 on both sides. So what should I be able to do by the end of the day? I can solve equations with a radical on one side of the equation. I can also solve equations with radical on both sides of the equation. I can solve equations with two radicals on one side of the equation. And then we're going to move on to graphing radical equations and explaining why the graph of the radical equation ends where it does. So let's go to the next page. So when solving radical equations, a good rule of thumb is you always want to get the radical or square root alone first. It's like when we're solving equations, we want to get the variable alone. We still want to get the variable alone in radical equations, but before you get the variable alone, if the variable is under a square root, you have to get the square root alone. So looking at number 1, the square root of 2x plus 7 minus 5 equals 6. So that entire left side of the equation is not underneath the square root. We want to get the square root alone first. So I'm going to add 5 to both sides. And now I have square root of 2x plus 7 equals 11. Now we have the square root by itself. So I'm going to now do what we did in the do now, and I'm going to square both sides of the equation y, because squaring is the inverse operation of square rooting, and that allows us to cancel the square root and the square. Like so. So we're left with 2x plus 7 on the left equals 11 squared, which is 121. And now it's just a normal equation solved from here. We subtract 7 on both sides. We get 2x is equal to 121 minus 7 is 114. Divide by 2 on both sides. And you would get x equal to 57. But before you go circling that answer, it's incredibly important to check to make sure that that's a potential answer. We could wind up with an answer that's not an actual answer to the original equation. So just make sure you check. And when I say check, plug in that x value in for x into the original equation. So that would be the square root of 2 times 57 plus 7 minus 5 equals 6. That gives us the square root of 121 minus 5 equals 6. And yeah, that'd be 11 minus 6. That is 6 equals 6. That checks out. That's good. So our answer is x equals 57. Now let's do number 2. Actually, I want you guys to try number 2. Take 2 to 3 minutes, pause the video, try number 2, and play it once you're done. Number 2 is very similar to number 1. It's the same format. We want to get the radical or square root by itself, so I'm going to subtract 12 on both sides. I get the square root of 4x minus 6 equals negative 4. I want to get the square root by itself. It is. We did get it by itself. So now I want to get the x alone, the whole sides being square rooted, so I can square both sides. So we have on the left 4x minus 6, and then negative 4 times negative 4, or negative 4 squared, is 16. Add 6 to both sides, and we have 4x is equal to 22. And last, divide by 4 on both sides, and you would get x is equal to 5.5. But make sure you check. You always have to make sure you check with radical equations. So check. I'm going to write check down here. And our answer was 5.5, we think. So that would be 4 times 5.5 minus 6 is all being square rooted, plus 12 equals 8. I would get 22 minus 6 on the inside there, plus 12 equals 8. That's going to give me square root of 16, which is 4. So 4 plus 12 is 16, does not equal 8. So 5.5 isn't our solution. We have no other solutions. So we have no solution. Our answer is no solution. That's why it's so important to check. Because if you don't check, you're just going to circle 5.5. But this is what we call an extraneous solution. So an extraneous solution is a solution found when solving an equation, but is not a valid solution to the original equation. So we rewrite this original equation a bunch of different ways to get x by itself. We rewrite it here, then we rewrite it here, we rewrite it here, and we finally get x equals 5.5. But sometimes that answer doesn't work with the original equation, so you have to always plug it back in. If it doesn't, that's what we call an extraneous solution. Think of extraneous, it means kind of like meaningless. So when it is an extraneous solution, we reject it. And our solution is just no solutions if there is no solution left. If you guys did the check in your calculator, then it would pop up with an error message. And that just means that it's not a solution. There is that 5.5 is an extraneous solution or a rejection. So I want you guys to do now part 2 and explain why you chose to do your first step. Take, 2 to 3 minutes, pause the video, and play it again once you're done. So what am I going to do here? I know we have to get the square root alone, and there's x's on both sides of the equation here. But watch what happens. We can just square both sides. And what happens to the square roots? Well, it cancels the square root on the left side, and it also cancels the square root on the right side. So all we're left with is 8x minus 1 equals 3x plus 4. We have solved a million of these before, so we just want to get the x's on one side, get the everything else on the other side. So I'm left with 5x on the left equals 5. Divide by 5, divide by 5, x equals 1. Don't circle that yet because we have to go over to the side and check our answer to make sure that's an actual solution and not an extraneous solution. So I'm going to plug that x value in for every x in the equation. So that'll be 8 times 1 minus 1, all under the square root, equals the square root of 3 times 1 plus 4. You would end up getting the square root of 7 equals the square root of 7. That is true. Check. So we can circle that as our answer, x equals 1. Now, why do you think we chose to do that first step? So we squared both sides. Well, I chose to square both sides. Chose to square both sides of the equation. And what did that allow us to accomplish? Well, we got rid of the square roots, but why did we choose to do that? Well, it's because the entirety, so the entire left side and the entire right side were both under that square root. So if we squared both sides, we would cancel that. So because the entirety of both sides of the equation are under a square root. And you could have said other things too. That's just the reason I would think of as to why I chose to square both sides first. Let's go to the next page. The do now part 3. I promise this is the last do now. So I want you guys just to take 2 to 3 minutes, solve this equation, pause the video, and play it once you're done. So what we're going to want to do here first, we're not going to want to square both sides. If you did that, you probably did it incorrectly. We're going to go over that second after I show you guys the best way of solving this. So instead of squaring both sides, what we're going to want to do here is I'm going to add the square root of 7x minus 3 onto both sides of the equation. What this does is it cancels that on the right side, and we're left, on the left side, and what we're left with is 3x plus 5 on the left, and on the right side is the square root of 7x minus 3. So now we have a square root on either side of the equation, and this should look very familiar to what we just did. We had a square root on either side of the equation up here. And what did we do to solve that? Well, we just squared both sides. So that's what we're going to want to do here. Once we square both sides, the square roots, both of them, will cancel. And we're left with, just on that left side, 3x plus 5. And on the right side, 7x minus 3. and we could solve it from here. So I always try, a good tip, always try to keep the x positive. That just helps you from making like a silly mistake when you're supposed to divide by a negative and you divide by a positive. So that cancels out the x here, and I'm also going to get all the other numbers on the left. So we have 8 equals 4x. Solve for x, divide by 4 on both sides, and you should get x is equal to 2. But do not circle that and say it's the answer just yet, because it might not be. You have to always check when we have radical equations. So to check, I'm going to plug 2 into our original equation. Always has to be the original equation. So that would be radical 3 times 2 plus 5 minus radical 7 times 2 minus 3 equals 0. You should get radical 11 minus radical 11 equals 0. And that is 0 equals 0. That checks. So now we can go back, box in our answer. It's correct. So before I show you the incorrect way of solving, let's talk about why we did that as our first step. So what did I do? Well, I added that radical 7x minus 3. So I added radical 7x minus 3 to both sides of the equation. And why did I do that? Well, that was in order to get the square roots alone on either side of the equation. So in order to get the square roots, and this is the big word here, alone on either side of the equation. Because the square roots are alone on either side of the equation right now, we can do the squaring of both sides in order to get the square roots to cancel. So now I want to show you guys the incorrect way. Brace yourselves. It could look it's going to look a little confusing because it's a lot of extra work and it doesn't really go anywhere. But here, I'm going to show it to you guys anyways so you understand why you can't just square both sides. So if you did square both sides of the equation first, you would have to, so on the left side, the black writing, you square both sides, you would have to write out as its factors, and then multiply, double distribute everything in the left parentheses by everything in the right parentheses, which gets you this. I'm not going to say that because that would take me 2 minutes of the video to say. You would simplify the inside. This looks confusing. It should probably. And then you combine like terms and you would get this. And then it would keep going and going and going. And I don't even want to try to continue solving that. I guess what you could do is add this stuff to the right side, then square both sides, or then divide by -2. It takes so much longer. So please just add the radical on both sides, and then bam, you're done. After you square both sides and solve for x. So what I want you guys to do now is just do the do now. The checkpoint. So do the checkpoint. 1, 2, and 3. Promise there wasn't any more do nows. So just do the checkpoint, the next 3 questions. Make sure you guys check your answer. That's very important for radical equations. I know some teachers always tell you check your answer no matter what, which is great. You don't always need to check your answer for some equations, but for radical equations, you do, to make sure it's not an extraneous solution. So pause the video, take 5 to 10 minutes, do 1 through 3, and when you're done, play the video, and I'll show you the answers. So here are the solutions. Check out number 1. We have to get the square root by itself first, so we added 2 first. And then we divided by -4 because the square root wasn't by itself. And then after we did that, it was by itself. So we could square both sides and then treat it like a linear equation solve for x. Number 2, we had two radicals on the same side of the equation. So I wanted to get one radical on each side of the equation, because that would then allow me to square both sides, which I did. So I squared both sides, and then I just get the x's on one side and the other numbers on the other side. But make sure you check for this one, because it does not work out. You get 4 equal to 0, which is not true. 4 does not equal 0, so you should have gotten no solution. And then number 3, the radicals were already one on the left side, one on the right side. So you just had to square both sides first and then solve as you normally do. Make sure you check. It did work out. So 30 would be our answer for number 3. Let's go to the next page. Now we are going to graph radical equations. So we want to graph y equals radical x. I want to first graph this using our calculator and then explain why it looks like that so you guys can graph it. So we're going to need a calculator. Gotta get one. Let me see. Wingardium Leviosa. Look at that. It worked. So what I want to do here is I want to graph. Our equation is y equals, clear anything out that's in there. We want to do second x squared, because that'll give you the square root of x. And let's check out its graph. Notice what's something that's glaring at you right now. Something that I see that's different than we have seen before is the graph seems to end at the origin 0, 0. We're going to talk about that y in a second, but let's just copy the table down. So looking at our table, after 0, 0, actually, when you get into the negative numbers, it says error. So there's no points there. So let's first just copy down our points that we have onto our page. So we have 0, 0, 1, 1, 4, 2, and 9, 3. And I only wrote down those points because those are the points with rational numbers. Also, they are all whole numbers, so they're easy to graph. I didn't want the other points because I'm not going to graph 3, 1.7321. We don't need to do that. We can just copy the whole numbers and plot each of them and then connect the lines. So plot each of them, connect them with a nice curve, and make sure you label it. That is y equals radical x. So let's talk about why it looks like this now. So if I look at, why does it end at 0, 0? Well, let's try and include, let's go to -1. Let's try and include -1 in on this graph. So I'm going to plug in -1 for x. That'd be radical -1. Radical -1 is not a real number. We can't actually figure out what radical -1 is inside of the real numbers. So there is no point when x is equal to -1. And that goes for any negative number. That's why it stops when x is 0. So let's talk about the end behavior. We kind of just talk about the left end behavior. So why does the graph of y equals radical x behave in the way you are seeing right now? Make sure you talk about the left end behavior, and let's also talk about the right end behavior. So first off, let's start with the left end behavior. So left end behavior. Well, if x is being square rooted, then x cannot be a negative number, or else it will not be a real number. Then x cannot be a negative number. Therefore, the lowest value that x can be is 0. This, therefore, is making the leftmost point, so thus making the leftmost point of the graph of y equals radical x 0, 0. We can't go any more left than that because our x is then going to be a negative number, and we can't have a negative inside the square root and maintain a real number. So we have the left end behavior here, ending at 0, 0. Let's look at the right end behavior. So the right end behavior keeps on going up and up with the arrow, but it's going up a little bit less as we go right and right, as we go farther right. So the right end behavior, I would say, as the graph continues to rise, it continues to rise, but at a slower rate as you go further right. And here's an example. So if you look, it's the y equals the square root of x, but as x gets larger, so it goes, radical 25 is 5, and then you go up 11 for the x to get to 6, and then you go up 13. So we're going up more and more in the x every single time, only to consistently go up 1 in the y direction. So we're going up at a slower pace as we go further right, but it's going to continue rise and approach infinity. So let's go to the next page. Take 2 to 3 minutes, graph the equation y equals the square root of x plus 2. You can either try and do it by hand, or you can do it using a calculator. Just make sure you show the xy table, pause the video, and play it once you're done. So I'm going to write my xy table here, x, y. And if you do it in the calculator, you're more than welcome to do the xy table. Just copy it on the xy table. So we have 0. I'll have a nice perfect square when x is 1, 4, and 9, because those are my perfect squares. So square root of 0 is 0, plus 2 is 2. Square root of 1 is 1, plus 2 is 3. And then square root of 4 is 2, plus 2 is 4. And the square root of 9 is 3, plus 2 is 5. So I'm going to plot each of those points. 4, 4, and then 9, 5. I'm going to graph my curve. And then make sure you label it. Always make sure you label a line. And that's all you have to do. So that's it for graphing and solving radical equations. We have the success criteria, which I would highly recommend completing, and then the classwork, and also the homework. So that is all.